Hey guys, here's another question. I don't necessarily think it'll be just like this on your exam because this doesn't cover as many different topics. But there's a couple of things in here that I think is important, and I'll go through that. I'll talk you through it as I go through. This first one, they're giving you the mean, standard deviation, and minimum, and they want to know if we think it's approximately normal. The way I approached this was to think, if it's normal, then almost all the data, 99%, fall within 3 standard deviations. We have the 68, 95, 99.7%. So if the mean is 4.6, I can go out and I can label 3 in each direction. And what I noticed was if the minimum score, if the minimum, hold on, score was 4.4%, this doesn't make any sense, right? There should be values below that 4.4. Okay? So I would try to put that into words. There's, I forget now, know how many people there are. Did it even tell us? A lot. Anyway, not normal. If normal, I expect values from 4.15 to 5.05 seconds. That is to 5.05. Since 4.40 is the minimum, it is not normal. Okay? I think that when I looked over the scoring guideline, they did it a little differently. So if you did it differently, you could still get it absolutely correct. The next part, it says to calculate and interpret the z-score. Z-score equals your value, 370, minus the mean, 310, divided by the standard deviation. You should get a z-score of 2.4. Okay? Make sure you answer both parts. It says to interpret. So this player what is this, lifting a weight, can lift a weight to, this player can lift a weight, and that weight, and that weight is 2.4 standard deviations above the mean of 310 pounds. Okay? Make sure they're going to do this to you, I'm sure. Calculate and interpret. sometimes people forget to do the second part. Just read it over when you're done. Make sure you actually answered the question. Okay, now they gave us player A and player B, and oh, you can only choose one of them. So if I go with player A and I want to compare them, I might as well. The only thing, if I have the mean and standard deviation above, I think the obvious thing to do is to compare their z-scores. Like I said, there's not a whole lot of topics on this question, but z-scores are definitely important, which is why I did it. So if I look at the running time, remember, and a smaller number time for running is better. So a negative z-score would be better for running. Maybe I should make a note. Oops. Negative z-score better for running. Okay, so player A, we get that the z-score is 4.42 seconds minus the average of 4.6 divided by 0.15. A negative z-score of 1.2. That's good because you want, remember, a negative z-score. And for the weightlifting, once again, calculating the ugly z-score, I get 370 minus 310 divided by 25, 2.4. Now a positive z-score for weight is good, so this goes pretty good. Let's see how player B compares. For the run, player B has 4.57 minus that 4.6 over the standard deviation of, okay, negative 0.2. Okay, so his run isn't as good as player A. So player A has a better run time. Okay, let's see. The weight, the z-score is, 375 minus 310 over 25. This comes out to 2.6. Oh boy. All right, so player A has a better run. Player B has a better weight lifting. So I guess it comes down to you explaining that player A is a significantly better runner and only a slightly worse weightlifter. So I think I would have to go with A, and I would have to explain that. Okay. How about that? Instead of making you sit through that, I would say player A is a much better runner because the z-score, the difference in their z-scores is a total 1, and only slightly worse, 0.2 z-scores in the weight. So I would go with player A, but make sure you write that down. Okay? All right, guys. Hope you're doing well.